Alright, we just talked about how to expand this, that this is the same as all of the sum of these terms. And in the sense of probability, I'll show you how this is useful. And so say, for example, you are taking a multiple choice quiz, and the quiz has 5 questions. And you want to get some of them correct, obviously. And it's let's say 4 questions, 4 answer choices, multiple choice answer choices per question, and you're just blindly guessing. You don't even not even reading the questions. It's the only way this is gonna match up to be random. And so A is gonna, let's say A is probability of getting a question correct, and totally random, just blindly taking the quiz, 25% chance. And we're going to call that letter A. And then incorrect, 75. It has to add up to 100%. So binomial implies only 2 numbers are used. If you have a 3-number thing, like this is a problem like pulling marbles out of a bag that are red, blue, green. Can't do it with 3 options. It's only 2 options, either or. Now, each one of these terms has a meaning based on the setup of this. So this was our A, and this was our B. And the first term right here, this would be like one branch of the tree diagram. Correct, 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 correct. Everything, get all 5 questions correct, and you would multiply 0.25 times 0.25 to the 5th power. And all 5 are correct. Now, we're going to introduce what's called a random variable, and we'll use letter X. X will represent, let's make it represent how many correct we get. Okay, so this would be X is 5 right here. And the reason why I'm introducing that, it seems like a extra information. It's going to make this a lot easier to write than correct, incorrect. Like this would be, this right here would represent 4 correct questions and 1 incorrect question. I'm not going to write that out. So the first one, let's calculate probability. We get all 5 of these questions correct just by guessing, and I'm going to write it like that. X will represent how many we get correct. Probability X is 5. That's this term. We're just going to go ahead and put 0.25 in for A. 0.25 to the 5th power, which is quite a small number. It's about 0.1%. Very unlikely, random guessing. No educated guesses, just completely random. Okay, now the next one here, 4 correct and 1 incorrect. And we can get, like that could be correct, 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 incorrect, or it could be like this, or it doesn't really matter which question if this is question 1, 2, 3, 4, and question 5. If we get the first question incorrect and then the rest of them correct, it really doesn't matter which one, so long as there's only one. Well, it turns out that there's 5 ways to do this. So those numbers from the Pascal's triangle represent how many combinations of correct and not correct, or pass, fail, or yes, no, heads, tails, whatever it is, binomial, one or the other. How many different ways to do that? So in the second way, there's 5 ways to do that. I just wrote them all out. In this case, there would be 4 correct, which would be 5 ways times 0.025, 0.75. Alright, we'll go ahead and work that number out. It's about 0.044. Okay, so 4%. And then probability x is 3 is the next one. This is about 9% for that. Okay, and so on. So that was this one. For 1, this one, this I didn't do this one. I won't write it out. I calculated it earlier here. 0.261, 0.400, 0.237, here. And it all adds up. All of these add up to 100%, as they should. It's all the options. And a lot of questions say, well, what if we don't really care that we get a specific combination? What if we only need 3 or more to pass? It's say we just need 60% to pass, and that's all you care about for this particular quiz. Well, that would be any of these 3 scenarios. You get 3 correct, 4 correct, or 5 correct, so we have to add them together. Now, 3, 4, and 5, we'll write it like this. Well, so long as we get more than 2 correct. And we could have written this greater than or equal to 3, but this works too. That'll be 0.001. We're just going to add these together, these three parts of this. So oftentimes when you're expanding, you don't need to go through the trouble of finding every single one of them, just the ones that are maybe relevant to the question. There is a convenient way to do this on the calculator. We will get there I won't show you that right away. This practice by hand first. Anyway, 0.044, 0.879. Okay. Now that adds up. Let's go ahead and do that. It's about, it's not exactly, but it's about 13%. Okay, it might seem a little low, but mind you, you're not educated guessing here, you're just randomly guessing. So we got all 3 of these scenarios all together represent about 13% of that possible outcomes. And then here you got 26, you got 40%, and 23%, 24% almost. And since incorrect is so much more likely, the weight of the situation is clearly in favor of not getting this, not getting 3 or more correct. So only 13% chance of getting more than 2 correct.